So just I'm sharing the screen here. Okay, so this is the next question here. The next question saying that construct a DFA that accepts a set of all string over AV such that number of A's in a strings are 2. Okay, so this notation numbers of A, I have denoted it like this. This N at to the foot of it there is written A, and it is contained in the string W, and W belongs to input alphabet A and B. Okay, so it says number of A's in W should be A, not greater than, not less than. It should be exactly equal to A. Okay. So I think uh, firstly you should try it yourself. Okay, so I will give you the solution in like uh, right in 2 or 3 minutes. Okay, so first try yourself. I will tell you the answer. Do not try to request the control. Okay, so you please Rajesh, do not try to accept the control. I will not give the control to you. Okay. Please try to solve this question, and please pass your screenshot in the chat box. Okay, Prachi, you are absolutely right. The automata drawn by Prachi is absolutely correct. And Vishwesh has also drawn a correct uh, automata. Yes, this is correct, Vishwesh. Okay, so again, I will explain you the three-step process that I follow. Okay, so the first step is I do not want to care about any number of B's. I just want the number of A's should be 2. Okay, so the first smallest string will be AA, and B can be anywhere. I do not need to worry about it. It can also this number of it can also possible that two A's come in this way, and in any way I just want two ways. B can be any number and anywhere. I do not need to worry about the B. Okay, so what do I do if I just want to write this, that I want two A's, and these two A's can be anywhere. If I just try to write a regular expression of it. Okay, so just don't worry about it if you do not understand the regular expression right now. Okay, I will explain you some parts in tune. Okay, so I am just saying that I B can come any number of times. So this star means 0, 1, 2, 3, 4. Star can be anything. If you remember the star from the first lecture, that star can be any number. So it is like an infinite thing. So B can come. infinite number of times, I do not need to worry about it. But A should be this after A, again B can come any number of times, and this A after B can come any number of times. If I want to write a regular expression of it, in this regular expression, just see there are only two A's, but the B can be any number of times. So I do not need to worry about this B. So if I just draw a automata of it, and if you see that this regular expression is going to be resemble the automata in a way. Okay, so I just need to start. The second step is to start with the smallest string, that is A. Okay, so A has to be followed by another A. Okay, so now if another A comes, now till here there is one A. Now in this state there is one A. Now there is two A. If another A comes, you know what to do. If another A is come, you just draw a dead state here. So I just denote it by QD. So okay, so any after it, it will trap in that state forever. Okay, so after, now see, I do not need to worry about B. So what do I do? This B star can be represented by a self loop here. Okay, so this B star is like this, followed by a here, and again there is a B star here. So I can again write a loop like this. Okay, so again it is followed by a here, and after that it can again B can come any number of times. So I do not need to worry about it. Okay, so every string that is possible will contain only these two A's. If you clearly see this, I have like hard coded this A. Okay, so these two A's will always come because it is not like a self loop. Okay, so in a self loop, it is also possible that if I just write a self loop of A, it means that A of star. Okay, so A of star means A can be zero. So it means no A can come. But if I write a like this on this arrow, so this becomes a permanent hard coding of A. So if I want to transition from this to this state, this A has to be considered. But if you do a self loop here, so it means A star, and A star, this star can be zero also. So it may or may not be considered. But if you hard code the A, meaning if you write this A on an arrow, it means that it is hard coded. Okay. So I think you understand these question now. I right now understand that this question, ninth question, I think you can do in 1 or 2 minutes. Okay, so this question is again very simple. It just say number of A's should be greater than or equal to 2. So it is saying that number of A's should be at least 2. It means 2, 3, 4 up to infinity. It depends upon only number of A's. I am not talking about anything of number of B's. So number of B's can be anything. Okay, so just try to solve this also, and please uh, give your answer in the chat box. Okay, Sparsh, in your automata, if you pass a string BA, so this string contains only two A's, one A, but it should not be in the language, but your automata is accepting it. So that is why you have to do a self loop of B in the starting state. Okay. Okay, Tushar has drawn a right automata. That is correct. I think Prachi has also drawn a right automata. Yes, yes, absolutely correct. So I think you get the point that now the automata is becoming fairly simple for you to understand it. Okay, Vishwesh has also drawn a correct automata. Okay, so I think you are understanding my point now. So well done. Uh, just go for the step here. The first step is always write the language. So the number of a should be greater than or equal to 2. So the smallest string that will possible will be AA. In the same way, any number of a's can be possible. And I do not need to worry about this B. I just need to worry about only the context of A here. So B can come any number of times. So do not waste your time on B's. Okay, so Mayank, your automata is again correct. So good. Okay, so if I just draw this, you reference it that I need at least two number of A's. Okay, at least two number of A's. After that, any number of A's and any number of B's can come. I do not need to worry about it. So this plus symbol means or. It says that any number of A and any number of B comes at any number of time. It just means a self loop of A or B. Okay, so firstly, I need at least 2 years. So if I write a regular expression of it, it can be written like this, that any number of B's can come. I do not need to worry about it. A should be there. And again, any number of B's can come here again. And A should be there. So 2A is necessary. After that, any number of A's and any number of B's can come. I do not need to worry about it. Okay. So this is kind of a regular expression. If you do not understand it right now, do not need to worry about it because it is further in the syllabus, and I will go pretty detailed about this regular expression. I'm just introducing to this notation that these are possible things. Okay. So again, go for the smallest string. You know about it. That is AA. So I'm just going about it. Q naught on A, it's going towards this Q1, and again on receiving an input of A, it is going towards Q2. Okay. So this is the final state. After that, any number of A's and any number of B's can come. So I do not need to worry about any kind of B here. B can come any number of times because I only have to take care of the number of A's here. Okay, so if you see the notation here, so this notation represents a self loop. It is followed by this. Again, it is A here again. Again, there is a self loop here. It can also be represented like this. Again, it is followed by A. After that, any number of A and any number of B's can come. So it is again denoted by a self loop in going in the final space. Okay. Okay. So again, the next question, I think most of you have already drawn it. Again, the next question is fairly simple. It just says the number of A's at most two. Okay. So at most two, it's less than or equal to two. Please draw it. Okay, so all the automatas drawn by Vishwesh, Tushar, Mayank, and Prachi are all correct. So well done. So I again, you know about the procedure again, what to do here. Okay, so the first is to write a language. Okay, so the language here is, you know about it, that it should not contain any number of a's. So it means that the b is like a b star. So it means we do not need to worry about b here. So there can be a possibility here that there will be a no a and no b also. So this is our epsilon state, that null string can also be accepted in this language. So just need to look out for that this is also possible. In the same way, it means only one b can be possible, so there is no a here. Okay, so another will be one a can be possible and two a's can be possible, and b's are, you know about it, b's can be anywhere, anytime, anywhere. We do not need to worry about b. Okay, so just keep in mind about this epsilon state, because I said that the number of a's in w should be less than equal to 2. So like if I say that I do not need to worry about it b, so I just say that b is like a b star. So for a self loop of it. Okay, so it can happen that this star can be 0 anytime, and there is also a possibility that a should be 0. So there can be a possible state that these both are 0. It means that this is a epsilon string, that these do not exist at a particular time. Okay, so if I just draw automata of this, right? Okay, so I will start with the initial state q naught, and I will go for the smallest string, that is your epsilon here. So to accept a epsilon, you know that we have to make your initial state as final state. After that, go for the smallest string again here. So it can be a again. Okay, so this smallest a should be accepted. So this is your final state again. In the same way, two a's should also be accepted. So two a's is again accepting. So this is your state q2. After that, any number of a's, if any number of a's are coming, it just go into a dead state and it just stays there. If there are greater than two number of a's, it should go to a state where it is not possible for it to come to the final state. That is why I'm calling this a dead state. Okay, so I do not need to worry about b. So b can be anything, so I just do a self loop of b here. Okay, so this is your answer. I think most of you have drawn it correct. Okay. Okay, so the next question again is a very simple question and based on the same lines that you have done. So I think now you will find these questions fairly easy to solve, and it just says the number of A's in this should be even. Okay, so it's just same question. In the previous one, we are just doing we just take care of the length of the string to be even. Now here we just want a particular string to be of length even. Okay, so it means number of a's in w, where w belongs to a input alphabet a and b, mod 2 is 0. It means we want number of a's to be even here. Okay, so just try it. I think it is very easy.
सर जीरो नंबर ऑफ एज को भी हम इवन कंसिडर करेंगे ना?
Yes, sure. Okay, so I have seen that all of you have drawn the correct automata. Again, it is based on the same thing. And Vishwesh, please don't post any offensive stuff here. Okay, so please take care of this. Again, go for the smallest thing here. So go for the smallest language that is possible here. So you know about this. If the number of A's in W, where W belongs to this A and B, it can be 0 here. So epsilon can be here. Okay, so if I say that B star, it means that B can be 0 at any time, and the number of A's should be even. So even A0 A's is also even. So it means that this epsilon can again exist there. In the same way, any number of even number of A's are 0, 2, 4, and any number. So I do not need to worry about this B. This B can be uh, anywhere and any number of times. Okay, so I just, if I do not care about this, I just denote it by a B star here. Okay, so star can be take anywhere. Okay, in the same way, just start with this Q naught, Q node, and it just goes towards this. Okay, so it is A, and again I do not care about this B, and number of A's should be okay. So this is your Q. Okay, in the same way, if you see the next question, I think uh, you are getting my point here again. So I just want to show you one point. If you just forget about this question, 12th question, you can do it yourself, but just do the 13th question. Okay, so I just want to clear one point and want to tell you, I want to generalize all the concept here in the end. If you just do this question, this 13th question or the 12th question is fairly easy. You know about this, what kind of automata will be built here. Only this has to be a final state, and this is just an initial state. So that is the answer of your 12th question. But just try this 13th question, and now in the end I will just wrap up all the concepts in one thing. Okay, so just do it. This is your last question of this type. Okay. Okay, very good. I think all of you have done the right thing and have drawn the quite good automatas, all of you. Okay, so very good. I think you are understanding all the automatas right now. So again, start with the smallest language. The W should be of modulus 3. It means just have to repeat the table of 3 here. So just start with the uh, epsilon here. So epsilon will also be in the language here, because 0 mod 3 is again 0. In the same way, 3 number of A's are possible, 6 number of A's can be possible, and you do not need to worry about B. So B can come at any place and anywhere. Okay, so just start with the smallest input again here. So this is the starting state, and that starting state has to be made the final state, because we have to accept the epsilon here. Okay, so I go for the smallest string. That after that it is A here. So A And again, if you can divert this input towards the end of it, so this will become our minimized automata. So this is A. So again, I do not need to worry about B, so I just do a self loop of B here. If you just see these type of questions very clearly, you will find that if you see this a number of A's in mod 3, sometimes people get confused that students get confused that how many number of states will be possible in this particular kind of a questions here. So if you see this question where number of A's W mod 3 equal to 0, you will find the number of state is 3. Okay, so number of states are 1, 2 and 3, and more particularly the final state here written here, the final state here is 0th. So this is the 0th state, this is the 1st state, and this is the 2nd state. So 0th state is final here, and these are the total number of states. If I want to generalize this formula, it can be generalized like this. In the same way, in the previous question, if you have a look about this, the number of A's and W and mod 2 is equal to 0. If you again have seen this thing, you will find that number this the number of states is 2, and the final state is 0th here. In the same way, if you look at this question and this question, if you draw it, it will be like this. If I just draw it rough like that, okay, so I don't need to worry about this, and this is your final automata for this question. And you will find this, it is accepting odd number of strings, and this is n of a w mod 2. Okay, so mod 2 equal to 1, and the number of states here are 2, and the final state here is 1. Okay, in the same way, this again the 14th question, if you draw it, most of time I will ask you that what is the number of states that are possible in it. So you know that the number of states here will be 3, and the final state, this is a final state, is the first, meaning this state is the final state in this automata. Okay, so this state, particularly this q1, is the final state in this type of a thing. So if I just say n number of A's in W and mod n equal to m. Okay, so in this type of a question, the number of states will be total number of states, and these states are minimal in nature. Okay, so if you do not know the minimization algorithm, so you can look at this generalization formula that you should not draw a number of states to be greater than the mod of n here. So number of states, minimal number of states, if I just say minimal number of states will be n here, and the final state in this particular question, the final state, the particular question will be n. Okay, okay, so I think that you have understood these types of question. Now again, if you want to do some practice, again you can change the number of that this mod, the mod of like mod 5 or 6. You can do this type of thing to check that that the validity of the formula is correct or not. Okay, so most of the 14 question, I think now you are able to do this. In the end, I will also provide you solutions of this in a word format. Okay, so all of the solutions, that is of all of the questions that are written in this ppt, I will provide you the solution and it will be uploaded in your LMS. So make sure to look about it. And I just now, uh, if I just extend this question to a bit, if I just raise the difficulty level of this question, that will be if I just copy and paste this question again here. Okay, so okay. So the 14th question now, please try to solve this question. It will be a bit, if I am just raising the level of these questions. The 14th question can be construct a DFA where W belongs to AB such that uh, number of K's in W mod, if I just start with the basic thing, mod 2 equal to 1, mod 2 for 0 here, and number of B's, and I am also defining the number of B's here, and the number of B's mod 2 equal to 0. Okay. So for this type of question, I am like raising the level of the construction of this automata. Okay, so see if you can able to do this kind of a question. I will tell you the solution. So try for 5 minutes. Okay, so I will tell you the solution. So try it one time. Okay, so Tushar and Vishwesh, please refrain anything that is not related to the lecture here. Refrain from posting it in the chat box. Okay, I am again requesting you to not do that. Uh, Please maintain a discipline in the class. Okay, so in this type of question, if you find want to build a automata, so there is a particular trick to design this, because this type of task becomes so much difficult, because to take care of both of these problems, we have to do a certain, we have to follow a certain kind of method. So it will be easy and we can keep track of the number of A's and number of B's here. Okay. So if I draw this by just looking at this, if I just looking at this, only looking at this, okay, I do not need to worry about this B right now. So if I only counting the number of A's here, so I am only counting the number of A's here. Okay, so you know about this automata we have previously drawn. It is a very simple automata. You know about this, that this, if this is a Q naught and this is your final state here. Okay, so I am again only designing the previous automata that we have drawn. Counting the number of A's, it will be like this. Okay, so again, okay, just wait for it. Q naught, and if I just name the state here Q1 here, and I am only counting the number of A's here. I am not counting the number of B's here, so I can just do this, not B's. So just remember this, I am not counting the number of B's here. So in the same way, if I just counting the number of B's here, I do not need to worry about A. I am not counting A's here. So this automata again can be built very quickly like this. If I just renaming the names here, because Q0 and Q1, now I am naming this as Q2 here. Okay, so Q2 and this. I'm again counting the number of B's here. So it will be Q2, Q3, and I do not need to worry about A. So this kind of automata can be drawn here. Okay. So now in this, we are just, if you see this and in most of the subjects like in digital, you have seen this add as a multiplication thing. Okay, so if you remember this, if this and in a truth table, you multiply it and place the values accordingly. For or, you always use plus. Okay, so same notation is used again here. So if I write a plus b, it means the or here. Again, if there is a and here, I will denote it by a multiplication. So it basically means that we are performing a cross product. Okay, so cross product. And in this cross product, you know the number of states here. So the number of states here is Q naught and Q1, and we are I just multiplying these two automatas here. Okay, so keep a look at it how this multiplication is done here, Q2 and Q3. Okay, so it will be, if you multiply these two states, you will get Q naught Q2 followed by Q naught Q3 Q1 Q2 and Q1 Q3. Okay, so now we will get our resulting number of states. I know that the number of states will be 4 here. Okay, so I just place it like this. Q0 Q3 is the name of the state. Another one, Q0 Q3 is another name of the state. Q1 Q2 is another name of the state, and Q1 Q3 is the fourth state. Okay, so if I just select this and move it down. Okay, so now I just need to define the transition of this. Okay, so again, look for this Q0 and Q2. Okay, so Q0 and Q2 on receiving an input of A is going where? Okay, so you have to now get back to your automata that you have designed previously. So Q0 on A, look here, Q0 on A, when receiving an input of B is going towards Q1 here, Q2 on B, Q2 on A here, we are doing the transition of A, Q2 on receiving an input of A is staying at Q2. So this state Q0 and Q2 on receiving an input of A is going towards the state Q1 and Q2. Okay, so Q1 and Q2 is written like here. Okay, so it can be like this A here. Okay, so now you can again derive all the solutions that are attached to it. Okay, so now this is exactly defined the transition of A. Now we have to define the transition of B on Q0 and Q2. Okay, the transition of B on Q0 on receiving an input of A is staying at Q0, and Q2 on receiving an input of B is staying is going towards Q3. If you see this, Q2 on receiving an input of B is going towards Q3. So the state, the transition of B on Q0 Q2 is Q0 and Q3. So both the transition have been defined here. Okay, in the same way you have to draw all of this automata yourself. Okay, so if you see now what will be the final state here, if you look at it, this in the previous automata the final state here is q node and here is q2. So the final state again here will be the q node and q2 here. So this again will be the final state. Okay. Okay, so again, just try to complete this question and please send the screenshot of it. Okay, I just for your reference I just keep it at your side. Okay, so I am again telling you to please complete this question so that you can understand it yourself. Again, I can complete it in a minute, but please try to do it yourself. Okay, so complete the solution here and post it on the chat box. Okay. If you have any doubt, you can again ask me here. Okay, again, Priya has done the right question, but I don't think you have completed the states like I have defined. If you look at it, the horizontal line, the horizontal way I have B, but you have A here, and there is no state defined. So I cannot verify it that what you have considered in your question. Okay, so it is correct, but I cannot verify it. Yes, Prachi has done the right thing. Just you have to do a final state on Q0 and Q2. Otherwise, the solution here is very correct. Okay, okay, Priya, you have done. Okay, okay. Don't worry about this. Okay, Veer Mali Kalyan. If you look at the okay. Kalyan, if you look at it in this, if I am counting A, the final state here is Q0 and here is Q2. So if both are this final in the previous in this particular kind, if we combine them both, so this is also final and this is also final. If I am multiplying this, so this is also final, this is also final. That is why I am saying this is a final state. Okay. We have to consider the initial yeah, because in this, if you see that we have want even number of a's, even number of a's and even number of b's. Okay, so 0 and 0 is also a even number. It means this epsilon string can come. So that is why I have made the initial state as final. So the initial will be the same as final state. Okay. Okay, I think you got the point what I want to say here. Okay, so if you just follow this procedure, you will find that this kind of pattern will be there. Okay, so this and this and this and this. Okay, so just keep I just want to show this because in the there are many possible combinations of this question. Okay, I can say that number of top mod here is 2 equal to a, and I can again say that number of b is mod 3 sorry, this is 0, mod 3 should also be equal to 0. Okay, So again, the same thing can be followed. The number of states is always a cross product here. Okay. So if you see, you know about this formula. If you look at this formula, it is just saying number of A mod 2 is equal to 0, and number of B mod 2 is equal to 0. If you remember the formula, that there will be two number of states in this one, and this is and, so I just multiply it, and two number of state for this. So if you multiply it, you will obtain the total four number of states, and the final state can be considered as zeroth number of state and zeroth number of state. So this is kind of a 0, 0 state. It means the starting state can be considered as a initial state. Okay. So in the similar way, in this particular kind of question, if I given you, you know the number of states will be 2 into 3, it will be 6. So this question can be extended to any number. Okay, so you can follow this method, and after a while you will find a certain kind of pattern how to do these kinds of questions. Okay, so this is a fairly simple one. In the similar way, there is a very good question that I find, and that question, if I just give you, that question is just says that. Okay, so if I just write that question says that a DFA, construct a DFA in which where W belongs to A and B, in which A is not A is followed by B. So this particular kind of a question is I consider this question as a very good and a beautiful question. What happens in this question is in this language, whenever there will be a, it has to be followed by a B. Okay, but in this language, if you see, if you write this language contains something called epsilon here. Okay, so most of you have the question that why this epsilon come in this language, because it only says that A has to be followed by B. It means that if A comes, that B is followed by it. So this is like a permanent string. If A comes, B should follow it. But what happens, we have not defined the scenario here, that what happens if there is no A, then what happens. Okay, so this is kind of a very interesting question. Okay, so in the discrete mathematics, you have also studied about this particular symbol called the implication. Okay, so if you remember the truth table of the implication, I will relate this concept to this question. Okay, so if you remember the truth table of this is like uh, 0 0 0 1 1 0 and 1 1. Okay, so the truth table and the output of this is only 1 0 0 here, and other output is always 1. So if you remember, in discrete mathematics you have studied preposition logic, and the implication, the truth table of implication is like this. Okay, I will explain you that why this epsilon comes here. Okay, so just try to do this here question yourself. We will discuss it in the next class. Okay. So thank you for listening. You can tune in your next lecture. Okay, we will discuss in the next class. Again, if you have any question, you can post it.